to further explain what is the difference between the voltage and the current. And just think about, so compare the charge with water. Actually, it's the same. Both the electric charge and water is a flow, right? So the energy, it is the voltage means it's a potential. So the potential to work is from the mountain. So the difference in height between the high end and the low end. So the large is this difference. The higher is the potential, right? That's for the water and also for charges. Another thing is you find a point here anywhere as a reference point, and you observe how many water flow past this point in a second. So compare these two flow. This one, for example, in a second, past this point, 5 liters, and this one, more than that or less than that. This perhaps 500 liters, right? Although the potential, this one is higher than this one, right? So the force, actually, if you measure the force, the water drop from the high end to the low end, the force is higher than this one. But the flow, so the current, this one is much more lower than this one. If result in injury, which higher energy, if you calculate, this is more dangerous, right? So this is high voltage. This is E life. High voltage and very low current. And this one is low current, low voltage, but very high current, right? Now you understand what is difference between E-life and the traditional electrical stimulation. This is the difference. So why with very high current? Because the high current drop, the water drop from the high end to low end is very high force, right? So it can penetrate to the very resistant tissue, even to bone, to others. So it's a whole body stimulation, because the aim of this machine, it's designed for improving health. It is not for treating a specific localized disease, right? And through improving the general health, perhaps the second result, it is the consequences to treat localized disease. And this one is like the traditional electrical stimulation. It's actually the force is not very high, but the current is so with low voltage, high current, and this provide only very localized stimulation, like the single muscle stimulation or just a nerve stimulation, but it's not a whole body stimulation. So any questions? Yeah, now we talk about not the effectiveness, but the safety. The safety is so whether it is safe. What about the current? Actually, you can feel it. If you don't feel any stimulation, then it is less than less than 1 milliamp. So it is quite safe. If you feel the stimulation just with the pen, for example, so it is higher than 1 MA. So with the increased current, the feeling is the body response ranges from very slight sensation, so 1 milliamp, to as possible, so muscle contraction, and then possible heart fibrillation, and so on. I'll just show you the range of the relationship between the level of the current and the body reaction. And E-life is a pulse high voltage. I would like to highlight again. This is high voltage, a low current treatment. and the low current is quite safe. This is why because the electrical energy can be converted to thermal energy, and accumulation of thermal energy result in the burn injury, like in the picture, right? But this is with pulse stimulation. With pulse stimulation, there is no accumulation of the thermal energy, and also there is no continuous contraction of the muscle, the excitable tissue. Yeah, and so quite important because it's a class 2, it's not class 1 safety. So when you use it, it's better use an insulated footboard. Yeah, just like you see this bird, sit here, it's quite safe because it's insulated from the earth. For the human, because the hand is visible and the foot is on earth, then there is a potential, the high end and low end. And then the charge flow can pass through the body and result in burn injury. This is why there is a insulated footboard. It is for safety.